Hello, everyone. In this lesson, we will focus on the implementation of cement concrete mixers control using S7-1200 PLC. The task for this lesson is the implementation of cement concrete mixers control using S7-1200 PLC. With the continuous development of modern urban construction, there is an increasing demand for concrete due to the growing number of infrastructure projects. The quality of concrete production directly affects the overall quality of these projects. As environmental awareness rises, authorities have mandated centralized production and management of concrete to reduce urban noise and dust pollution. This not only necessitates high-quality concrete but also requires fast production speeds and good environmental performance. Consequently, automated concrete batching plants have become a development trend. PLCs are widely utilized for automated control due to their high reliability, comprehensive functionality, and simple, intuitive programming capabilities. How to use PLC to control a cement concrete mixer? Let's first look at the specific task requirement. The PLC controls a cement concrete mixer. When the start button is pressed, the motor runs forward for 10 seconds, then stops for 5 seconds, reverses for 10 seconds, and stops for another 5 seconds. This sequence should repeat for a total of 15 minutes. After the mixing process is complete, a warning light should flash at 1-second intervals. The mixer will stop working when the stop button is pressed or in the event of a motor overload. Next, we will implement the task by defining the I/O address assignment table according to the control requirements for the cement concrete mixer. The input variables include the start button, stop button, and overload sensor, assigned to I0.0 through I0.2. The output variables include the motor forward and reverse contactors, KM1 and KM2, and the warning indicator light, assigned to Q0.0 through Q0.2. Based on the I/O address assignment table, the PLC peripheral interface wiring diagram is shown in Figure 8.2.1. The system start and stop buttons, SB1 and SB2, overload relay, FR, and warning indicator light can be directly connected to the PLC. The forward and reverse operation of the mixer is controlled by the motor, which requires intermediate contactors to drive the AC contactors KM1 and KM2. Design and write the control ladder diagram according to the control requirements, as shown in Figure 8.2.2, which consists of a total of 6 segments. Program Segment 1 is the initialization operation performed after the PLC starts running. It uses the first scan bit M1.0 to reset all output interfaces and memory bits to 0. Program Segment 2 controls the start, stop, and alarm indicator light flashing for the cement mixer control system. When I0.0 is pressed, M2.7 is activated and self-locks, indicating that the mixer is running. The T5 timer starts, and after 15 minutes, M2.7 disconnects, stopping the mixer. A TP timer generates a 20-second pulse to make the alarm indicator light Q0.2 flash at 1-second intervals for 20 seconds. Program Segment 3 controls the forward operation of the cement mixer for 10 seconds. When I0.0 is pressed, the Q0.0 coil is energized and self-locks, indicating that the mixer is rotating forward. The T1 timer starts, and after 10 seconds, Q0.0 is deactivated, stopping the forward rotation of the mixer. Program Segment 4 controls the stopping of the cement mixer for 5 seconds after it has rotated forward. When M2.0 is activated, the M2.1 coil is energized and self-locks, indicating that the mixer has stopped after rotating forward. The T2 timer starts, and after 5 seconds, M2.2 is activated, causing the mixer to begin rotating in reverse. Program Segment 5 controls the reverse operation of the cement mixer for 10 seconds. When M2.2 is activated, the Q0.1 coil is energized and self-locks, indicating that the mixer is rotating in reverse. The T3 timer starts, and after 10 seconds, Q0.1 is deactivated, stopping the reverse rotation of the mixer. Program Segment 6 controls the stopping of the cement mixer for 5 seconds after it has rotated in reverse. When M2.3 is activated, the M2.4 coil is energized and self-locks, indicating that the mixer has stopped after rotating in reverse. The T4 timer starts, and after 5 seconds, M2.5 is activated, causing the mixer to rotate forward again, initiating a new cycle. You should create the project, define PLC variables, and complete the programming and downloading processes on your own. Once the program has been downloaded, we will proceed to debug and monitor its operation. Start the CPU, enable monitoring, and open the simulator. The first scan bit M1.0 is activated to perform initialization operations. When the start button is pressed, the system begins to run, and the mixer starts rotating forward. Timers T1 and T5 are activated. After 10 seconds, T1 causes the mixer to stop rotating forward, and T2 starts timing. After a delay of 5 seconds, T2 triggers the motor to reverse. T3 then starts a timer, and after 10 seconds, the mixer stops reversing. Following this, T4 is activated. After T4 times for 5 seconds, the motor rotates forward again, initiating a new cycle. When T5 reaches 15 minutes, the system stops, and the mixer ceases operation. A TP timer generates a 20-second pulse, causing the alarm indicator light Q0.2 to flash at 1-second intervals for 20 seconds. The above outlines the operational monitoring process for the cement concrete mixer control using basic PLC instructions. After class, we can experiment with different instructions to meet the task control requirements. That concludes this lesson. Thank you, everyone.